Okay, this is Math 2, Unit 10. This is Buchanan High School's Lesson 1, 10-1, kind of how we're running through our things. If you're on the school site, you might have a different order. I'm just basically going to go through the worksheets that are part of the Unit 10 in our Pearson textbook as well. If you look at our website, you'll see some other lessons that might explain different portions of this done by other teachers. And so kind of follow those to see what the rules are going to be. I'm going to go through this worksheet, which has lots of rules all joined together. So here we go. Let's start with number 1. First of all, it says rewrite each expression using each base only once. Recall that if it has the same base, then all we're going to have to do is take the exponents and add or subtract them together. I'm going to go ahead and zoom in a little bit. Sorry about that. So in this case here, I have a base of 10, and my exponents are a 7 and a 2. So I simply add those together, and that becomes 10 to the 9th power. Looking at number 3, I have the same bases, 7, 7, and 7. So my base will stay a 7. Now for my exponents, because of the same base, I combine them together. Now I have an 8 minus 1 minus 5. So that's going to be 8 minus 1 is 7, 7 minus 5 is 2, and we're left with 7 to the 2nd power. Okay? So we're just taking the exponents and we're adding them together to find the final solution there. Okay, number 7 down below. This one's a little different. I'm not sure if you saw this one in your class or not. This is actually going to show up, I believe, in one of our later lessons on our web videos. I think it's one of the ones like it's 10.4D or B, one of those ones where you're dealing with fractions as a radical. So what do we do here? It's a little different. Think of it like this. If I had, for example, just an example, if I had the number 3 to the 1/2 power, that is another way of actually writing down 3 to the 1st and the square root of that. Okay? So what we're saying here is the bottom number becomes our radical and our top number becomes our exponent in the problem. So in this case here, 27, I take the 27, the top number is my exponent, so it's just to the 1st power, and the bottom number is my radical, so this is going to be root 3. It's how it looks if I write it out in that form. What it's asking you is it's asking this question: what can you multiply by itself 3 times and get 27? Okay, so what number can I multiply by itself 3 times and end up with a 27? Essentially what we're asking it to do here. So I happen to know, and maybe you do too, if you think about 27, 27 is 9 times 3, right? 9 times 3 if I break that apart, and then 9 can be broken apart as 3 times 3. So what I really have is 3 times 3 times 3, or essentially 3 cubed underneath a cubed radical, which means that that is going to make that cancel out, so I'm left with just 3. Alright, a little different there, but that's just one of those. So I wanted to make sure you saw that one there. Not sure if you'll see that necessarily later on, but now you've seen it now. Number 8, similar one here. Again, the top number is our radical, is our exponent, so this becomes 9 to the 3rd, and the bottom number, the 2, is our radical. It's just a 2, so it's just a square root of that. And so what you could do here is you could just multiply that out. You could say, well, what I really have is I have the square root of 9 times 9 times 9. And if you're not really sure what to do there, just multiply it out of your calculator. 9 times 9 times 9 actually gives you the square root of 729. And if you use your calculator to find out what the square root of 729 is, you find out that it actually is 27. So a little different. Again, not sure how your teachers covered that in class or what they want you to do. They might have a different trick for that. But that's how I went about solving that one there. Okay, let's look at number 9. Number 9, back to some regular expressions here. We have 7 times a to the -1 power, and we have a -3a to the 5th power. Alright, so what I'm going to go ahead and do is first of all multiply together my regular numbers, my whole numbers. So 7 times a negative 3 is a negative 21. And then when I look at my, my variables here, I have a to the negative 1 power times a to the 5th power. And because, again, the bases are the same, a, I just add the exponents. So a negative 1 plus a 5 leaves me with a 4. So it's going to be negative 21 a to the 4th power. So again, multiply your whole numbers together, and then look at, because of similar bases, 5 minus 1 is 4, and that's what you get for a. Number 11. Similar idea here. The trick here is to remember that even though it just says m with nothing there, it's actually m to the 1st power. So then I really have m to the 1st, 4th, and 2nd. So 1 plus 4 is 5, plus 2 more is 7. M to the 7th power is what I end up on that problem there. Alright, let's look at number 12. 12 is a log number 8. Again, we're going to go ahead and multiply together our whole numbers. So 8 times a negative 5 gives me a negative 40. Now looking at my h's, I have h to the 3rd times h to the negative 4th. Now because the base is the same, I keep the bases and I simply add together my exponents. So 3 plus negative 4 ends up with a negative 1. Now for our answers, to really simplify this though, we don't want to leave a negative exponent in the problem. So the way you properly write this is you would actually say it's negative 40 over, and when I have something to the negative 1, that means to drop it down to the denominator, so it just becomes an h in the denominator. Alright, number 15. Looking at our 15 here. Interesting because 15 is going to be on scientific notation. I am not sure if you're going to be seeing much scientific notation in your work that's ahead. I don't know if you cover this in class or not, but just in case, let's go ahead and go over this just briefly. So what we'll do with scientific notation is we're going to go ahead and multiply the first numbers, 2 times 4, to get an 8. And then we're going to take our 10 to the 6th and 10 to the 9th, and they're the same bases. And again, because of the same bases, we're going to add the exponents together. So 6 plus 9 is 15. And that's all we're going to do there. When I do number 17, it's something similar, except that with scientific notation, you only have a single digit in the ones. You can't go to the tens place. If you look at them all, it's a 2, a 4, a 3, a 3. You don't have 39. So what happens in 17, if I multiply negative 7 and negative 8, I end up with a positive 56. Right? I'm going to go ahead and leave it there for now. So 56 times, let's do our 10. 11 minus 4 is going to be 7. But I don't want to leave it as 56. I want to actually move that decimal over 1. So to do that, I make it a 5.6, and because I moved it over 1, then I'm actually going to make sure I increase the value of my 10 base to 10 to the 8th power is what I'm going to do there. Okay? Let's look over here at number 20. We have and find the area of the figure. Area for a triangle is 1/2 of the base times the height. In this case here, we have 1/2 times the base is 4z squared minus 10 times the height, which is 8z. Alright, so that's my basic setup there. I'm going to go ahead and hold off on this for now. I'm not going to worry about the half. I'm going to go ahead and distribute my 8z. So an 8z there, I do my 8 times 4 is 32. A z to the first times a z to the second becomes z cubed. And then I'll do this one. 8 times negative 10 is negative 80. And I just have the z, so I'm there. Alright, doing good so far. Now this whole thing is times 1/2, or another way of looking at it is the whole thing divided by 2. So now I can look at what is 32 divided by 2. That would be 16z to the third, and negative 80 divided by 2 is negative 40, and the z just stays as it is. And that's my answer there for number 20. One final one. Again, I'm not sure if you had to do the scientific notation, but I went ahead and said let's just do number 20 real quick, because it has one of those move over kind of deals. So number 20, Lake Ontario is the smallest of the Great Lakes with a surface area of 7.34 times 10 to the third miles squared. The surface area of all 5 Great Lakes is 12.5 times the surface area of Lake Ontario. So what is that surface area? Essentially what we're going to do is we're going to say, well, let's take our 7.34 and let's multiply it by 12.8 because it's that much larger. Well, 7.34 times 12.8 gives me 93.9, right? And that's going to be approximately 94. I'm going to go ahead and keep this initial 10 to the third because that's just what I started with, times 10 to the third there. But because I don't want to leave it in two-digit form, I'm going to move the decimal over there. This will become 9.4, and by doing that, I need to increase this to 10 to the 4th power. So it's not a complicated problem. We're just multiplying the 12.8 to 7.34, figuring out about what it is, moving the decimal over, and making it 10 to the 4th power. All right, that's it. I hope that helps a little bit. I would recommend kind of looking at all the various videos there that are on our website. They're not always in order with the lessons for this unit, but there's a lot of really good information on the different videos that are there, so keep checking them. When I went to do this homework assignment, I basically watched through most of kind of lessons 1, 2, 3, 4, and 5 to get all the rules together in order to figure out what's happening on these pages. So see what's happening in your classroom, but I'd encourage you to watch a lot more of the videos to figure out what's going on. Thanks.